Hey everybody, today we're going to be talking about ratios, proportions, and percents. So we're done with the equations and their applications. This is actually one of the applications of linear equations. We're going to see how to solve especially problems involving percents using linear and first degree equations. So let's first start with ratios. Okay, so ratio basically is when you have two quantities or more that are related to each other. Uh, for instance, when you say two items cost, let's say $5. Okay, and more items will cost more dollars based on this, what we call ratio. So the ratio is 2 to 5 for two items for 5, or you can say 2 to 5. You can write it this way. You can also say 2 to 5, or the symbol of the ratio, which is actually 2 colon and 5. This also means 2 to 5. This is the actual symbol of ratio. It just means 2 is related to 5. Two quantities that basically are related. You can also use 2 per 5, for example, 2 items per $5 or something like that. And also, as a fraction, we can say 2 over 5. Okay, so all these pretty much mean the same thing, just a notation for this ratio. So, like I said, these two are related. So if the number of items changes, the amount also changes accordingly, or what we call proportionally. So if you buy in, so 2 for 5. So if you're gonna buy, let's say, 4 items, what would the cost be? Everybody? Would be 10. Okay. Let's hold on a second. Okay, so these change accordingly or proportionally. And based on this ratio, you can calculate how much money you need if you want to buy X items, whatever, 4, 10, 7, whatever. You can figure that out based on this. Or if you have a certain amount of money, you can figure out how many items you can buy with that. For example, let's say you have $20 here. $20. How much or how many items can you buy with $20? If you can buy 2 for 5, let's say you want to spend all this money on the items. So how many items will you be able to buy for $20? So if you look over here, so you have 5. 5, we turn that into 20. So what happens to the 5 to turn into 20? Basically multiply it by what? 5 to get into 20. By 4. So the other one should also be multiplied by 4. Okay, 2 also would be multiplied by 4. So we get 8 items. Okay, these two, we say they are proportional. So 2 for 5, 4 for 10, 8 for 20. So this changed into 20 by 4, also by 4. Or you can look at it from here. This basically doubled. This also doubled. You times this by 2, you times this by 2. Okay, so all based on this ratio here of 2 to 5. Another example is, let's say you're, you have this ratio here. For example, we need 3 slices per, I don't know. Let's say you have some people and each person let's say, requires 3 slices of pizza, whatever. So you're having a party and people, each person needs 3 slices of pizza per person. So based on the ratio, if you have, let's say, 7 people coming over, then you would know how many slices of pizza you will have. So 7 for 1, 3 for 1. So how many slices would you need for 7 people? If you need 3 slices for each person, right? So how many people or how many slices you're gonna need for 7 people?
21.
21, that's right. Simply, again, if you want increases, the other one has to increase with the same amount, or proportion. So the number of people went from 1 to 7. Basically, we times that by 7. Same thing here. So the number of slices of pizza should also go up by the same number or same ratio, which is times 7. 3 times 7 is 21. Let's say an example of cooking. Let's say the recipe requires, let's say, 1 cup of flour, maybe 3 eggs, and maybe 5 tablespoons of butter or oil. Okay, so flour, for example, this is eggs and some oil or butter. So this, for example, makes 1 pie or whatever, or 1 cake or something. So if you're gonna make more or make less, you have to change these accordingly, okay? Not randomly, but accordingly or proportionally. So if this, for example, makes 1 pie, so if you're gonna make 2 pies, you're gonna double all this. You're gonna make 3, you're gonna triple them, and so on. So for example, you wanna make 2 pies here. All of these will be doubled, so it will be 2 cups of flour, 6 eggs, for example, and 10 tablespoons of butter for 2 pies. So that is a concept of ratios. So quantity to another quantity or more quantities together, because they're related, their amounts depend on each other. If one increases or decreases, the other one should also increase or decrease proportionally. Speaking of proportions, so again, it just means, let's say, if you have this ratio of 5 to some number, 4, if this one increases, again, the other one has to also increase proportionally. Say 5 for 4. So 10 will be to what number? 5 to 4 is the same as 10 to?
8.
Exactly, to 8. Okay, because we doubled this one. We gotta double the other one. And to confirm or to check that this is actually true, you can say, you can check the proportionality by multiplying, by cross multiplying. You can say, if we cross multiply, this should be equal. Proportionality. Okay, so we can do 5 times 8 and must be equal to 10 times 4. If they're proportional, that must be true. So 5 times 8 equals, we say, is it equal to 10 times 4? In fact, this is 40, this is 40, so that's true. So this is reliable, okay? This is reliable, proportional. If you're cooking or you're buying something or doing anything with these numbers, you can go by these proportions. So let's say you're buying, I don't know, 5 drinks for $1. Okay, 5 drinks for $4. And let's say you want to buy 10, so you want to trying to figure out, so you're going to need 8, and so on. Sometimes you need to do the math in advance. Let's say example here, example of pie again. Let's say you know how to make one pie. For example, that pie is enough for, let's say, 5 people. So you can do the math and see how much to make exactly if you have like 25 or 37 people coming over. So based on this, you can do the math and calculate exactly how much of each ingredient you're going to buy and mix and so on. So that's the use for the usefulness of these ratios. So you can say here, yes, the ratios are proportional. Proportional or proportionate. They pretty much mean the same thing. Proportional or proportionate are the same word as far as I know. You can use them interchangeably. Let's see. Let's make up another problem here. Say 3 to 5, 4 to 11. Are these two ratios proportional? If yes or no, explain. Are these two, if we do the same method here, are these two ratios proportional?
No,
Okay, why do you say so?
because if we cross multiply, 3 into 11 equals 33, and 5 into 4 is 20.
That's right. So the cross multiplication proportional. Are these proportional? So again, just take cross multiply them. So 3 times 11, and we say is it equal to 4 times 5. That's 33. This is 20. So obviously these are not equal. So you can't rely on this proportion. It's wrong. The formula here is not going to help. If you use it to buy items or to cook stuff, something will be off and you won't get the result you desire. So you say the two ratios are not proportional. Okay, that's basically how you figure out whether two proportions or two ratios. So a proportion is made of two ratios. So each one of these, you have a ratio, you have another ratio. In order for this to be a proportion, the cross multiplication must be equal. Otherwise, the two ratios, they're unrelated, they have nothing to do with each other, because there is no equality when you cross multiply them. Okay, so you'll be given something like this to check if it's proportional. Or you may also have a missing number. You will be given a proportion with a missing quantity, and you figure out that missing quantity. And that's basically, we use pretty much the same method here of cross multiplying to find a missing quantity. Let's see how to do that. So missing. Quantities. So assume this proportion has, let's say, 5 to 3, and then we have 7 to x. So here it is assumed that it is a proportion. Okay, there's two ratios, so it will be assumed that this is a proportion. We just need to figure out the missing number. So it's pretty simple. What you do is we cross multiply. And this will turn into an equation. So 5 times x should be equal to 7 times 3, because this is given as a proportion, so these must be equal. And then you just need to figure out the missing number. So you turn this into an equation. Again, this is one application of the first degree equations that we learned. So we learned them so we could use them to solve actual problems. Okay, now that we have this equation, what do you do now to get the x? What is the one step to solve this and get the x? Five times x is 21, based on what we learned so far with the first degree equations. How do you
Divide by 5.
That's right. You just need to divide by 5, one-step equation. So it's similar to what we saw before with cross multiplying. You can think of this as a fraction, 5 over 7, 3 over x. You just cross multiply. So x is 21 over 5, or you can also write it as a mixed number, 5. How many times does 5 go into 21?
4.
4.
4 times. Okay, and what's the
One.
remaining? 1 over
5.
5. That's right. It makes more sense when you turn these into this, especially if you're dealing with, let's say, pizzas or pies or number of items. So you want to make sense of the answer. So let's say this was about pizza, for example. What about something, it's going to be 4 pies, for example, and some change. Or if we're dealing with money, for example, the amounts or prices, you may want to turn this into a decimal, 4.2 in this case, 4.2, for example. So that's how you basically find the missing quantities of any proportions. Just cross multiply and simplify. The x here, by the way, could be anywhere. Could be anywhere here, but the method is the same. You could, for example, have, a number x to, let's say, 4. And this ratio, so x to 4 is the same as 5 is to 3. So if 5 to 3, we need to figure out the x. Same way, cross multiply. Always start with the multiplication of the x on the left side, and then the other multiplication. Still the same, but we want to have the x on the side. So x times 3, that's 3x. And 20 on this side. And again, divide by 3, divide by 3. So x is 20 over 3, which is 6 and 2/3. Okay, the x will be somewhere in this proportion, in these quantities. We can find it by cross multiplying. Or proportions also can be as fractions, okay? We said we can write them in this form, or that like this, as a ratio. This is a symbol for ratio, or 2 per 5, or a fraction. Either one of these will be fine. This with the arrow makes more sense. It says 2 to 5 and so on. This probably makes more sense, but you can also use fractions. You can say x over 5 is the same as 4 over 3. And you cross multiply, you get this either way. Or you can even say x over 4, 5 over 3, or 4 over x, 3 over 5. You can do it any way you want, as long as you do it in the same direction. Or even 3 over 4, 5 over x. Because these are proportion, you can do them any way you want, as long as you do them both in the same way. Okay, so now, problems like these are not always given like this as ratios. Most of the time you'll find these in a word problem. Word problem that you turn into ratios. Once you turn them into ratios, you can easily solve them. So let's see some examples of these word problems. There's a common, say if 4 items cost $11. So the numbers are not always convenient, like this 5 to 4, 10 to 8. It's not always convenient to figure out easily. So they can be a little inconvenient with maybe decimals, or not simple numbers that go into each other. So for example, if 4 items cost $11, how many items can you buy? Well, let's say we have some amount here, maybe 37. Okay, so we need the exact number. We need an accurate answer, so precise answer. Sometimes the numbers can be convenient, like I said. We can do the math in our heads. Other times you may have to do it actually manually to find, especially if you're looking for a precise answer. You may get an estimate from here. You could probably estimate how many items, but let's see exactly how many items we can get with the decimal point. It's got to be a decimal point based on this, because the numbers don't go into each other. Okay, so if 4 items cost $11, how many items can you buy with $37? Okay, so you want to buy some stuff, you want to spend all your money on that stuff, whatever it might be, whatever you have in your pocket, you want to buy all or spend all of that on it. This is a ratio that's displayed on in the store on the item, and you have this much money. So you can do a little math and figure out how much or how many you'll be able to buy. So first thing you want to do is we're going to turn the problem into something like this. Okay, once you have these two ratios, you're almost done. Just need to cross multiply and solve. And we get those from the problem based on what we have. What do you think the first ratio is? So we're going to need two ratios like this. What's the first ratio based on the problem? What are the two quantities, first ratio? What to what based on the problem? Based on what's given basically here. Something like this. We're going to need two of these two ratios. What is the first one based on this sentence basically? 4 items cost 11. So that's the first ratio, 4 to 11. Okay, that's it from this word problem. Now we just need to do the other ratio. The other ratio is missing something, it's missing the number of items. So we're going to have an x somewhere here. Okay, so what's the second ratio, or where does the x go in this second ratio? Everybody, so give me the second ratio here. Basically, second part, but the first part is this one. Second part is items. You can buy with 37. So this slide here is for items.
X would be the first part, and 37 would be the next part.
That's right. So we have items to money, For the second ratio, we do know the money, so it should go under the money here, so 37. And the x, that's what we're missing, the number of items. X should go here. Okay, so that's almost done. What is the next step to find x?
We would cross multiply.
That's right. What's the first cross multiplication?
4 into 37.
437, or you can start, it's better to start with x, it doesn't matter, so it's excellent.
Would it be 11x over 11?
So one multiplication this way, so 11 times x. What's the other one?
4 times 37.
That's right. That's all. So cross multiply and always start with the x. You want to put that on the left. Now we can multiply. You can say 11x, 4 times 37. What would that be? 74, 120 something.
148, I believe.
148 sounds about right, I believe. One 48, 37, 148. That's good. And then, of course, divide by 11, divided by 11. Let's divide that 148 by 4 by 11. It's 13.45. 13.45, but we're looking for the number of items. An item has to be a whole. It's a, for example, if we're talking about drinks here, so basically you say 13 drinks, so 13 items. You have a little bit left here, some change left, but it's not enough to make a whole item. Unless it was money. If we were talking about money, this would be $13.45. But here, just say 13 items. You got a little bit of money left based on this change. That's one example. And you can switch the words instead of items and dollars. You can use people and pizzas or money and something else. It's going to be pretty much same type of problem. The words might change a little bit, but it will come down to something like this, regardless of the words of the problem. Okay, that's one of the problems. Any questions about any of this so far, everybody?
No.
Kevin, Maricela, Troy. Any questions here about all this stuff so far?
No.
Okay, so let's look at another word problem. This time, let's say a car is traveling at some speed, maybe, I don't know, 40 miles per hour. And we'll say how long will it take the car to travel, for example, some distance or whatever, let's say 200, maybe 150, for example, 150 miles. Okay, so let's say you want to go from place A to place B, and you know, for example, there's a speed limit for whatever reason. You can't go over 40 miles per hour. You want to figure out how long it will take you to go from here to here. So if you start here at some time, okay, start at T, whatever time it might be, you want to know what time you're going to get there exactly. So you can do a lot of math here. So if you know the distance from A to B, which is given, it's 150. and you know the speed, or your speed, for example, a steady speed of 40 miles per hour. So you want to figure out what time do I get there or how long it's going to take me. So this is basically another problem we can solve with ratios. So first, of course, when you solve a problem, you want to understand it first. You may have to read it a few times. You may have to sketch it a little bit like this, the way you want, and so you know exactly what you're looking for. So, car is traveling at 40 miles per hour. How long will it take the car to travel 150 miles? So this whole distance is 150. You might be able to probably approximate it, especially if the numbers are, let's say, convenient. If this was, for example, was 80 miles here, you would know that you're going to need 2 hours, 40 for each, 1 hour for each 40 miles. But 40 doesn't exactly go into 150 evenly, so you will have to do some math to find a number like this with a decimal. Okay, so we're going to need two ratios here from the problem. So the first sentence will have one ratio, the second sentence will give us the second one. What is the first ratio based on the first sentence?
40 kilometers for an hour.
That's
40
right.
miles for an hour.
That's right. 40 to 1. You can say 40 to 1. So hour and miles. 40 to 1. Second ratio, something is missing. Where do we put the x? Looking for how long?
150 miles for X.
That's right. So we have miles. We don't know the hours. So we're going to say x hours. We put a question mark. So it's important, again, to put the x in the right place. Miles to hours. The other one should also be miles to hours. If you start with hours, you got to start the other one with hours. And that's pretty much the problem here written in this form. It's pretty much the same information. Now we just need to figure out the x simply by cross multiplying, as we've done here multiple times. Always start with your x. Okay, start with the x multiplication. 40 times x. Of course, 150 times 1 for hour. 40x is 150 times or divide by 40. X will be, you can cancel the zeros out. 15 over 4. So you could say
It's going to be 3, and the leftover is going to be 3 over 4.
4 into 15, not
12.
oh,
There goes,
okay, that's right. And
there's 3 left over.
3
3/4. Yes.
That's right. So 3 hours and 3/4 of an hour. If you want to put this in minutes, so 3 hours.
That's a question.
Mhm.
We're always going to use the number that's multiplied into X as the bottom number that we're going to divide by, right?
That's right. So whenever you want to get the x by itself, you want to cancel the x, the number next to the x. That's when you divide by that number to cancel it, to get the x by itself, not the other number. Okay, so approximately here, how much time is this? 3 hours, and what's 3/4 of an hour in minutes? What's a quarter of an hour? 1/4.
15 minutes.
That's right. So 3/4 of an hour would be
45 minutes.
45 minutes. Very good. Okay, so when you do your math, let's say you start in here at whatever time it might be, t0. Okay, this tf or t final. So whatever time you start, you're just going to add 3 hours, 45 minutes to it. Unless you cross a time zone or something, then it can get a little confusing. But let's assume you're traveling within the same time zone, so you don't have to deduct add hours. So exactly 3 hours and 45 minutes, you'll reach your destination from destination B, traveling from A. Okay, you see how this is going to be useful again when you're looking for a precise answer. Okay, so a lot of word problems can be easily solved like this. You see these in the tests a lot. You see them in the placement tests, computerized tests. It's very simple to turn any problem into this. Once you do, you solve it. So that's ratios and proportions. Finally, we're going to talk a little bit about percents. Percents are another very important topic here. Again, not only for this math class, but that's something you use pretty much all the time, whether you're cooking, you're shopping, or you're doing your math, your finances, or estimating things, doing things. And also in your classes, let's say this math class itself, maybe business, a lot of percentages and ratios in businesses. In the medical field too, there's a lot of calculations of dosages and other things. So it's all around a very important and useful topic. Number 3. Okay, so percents, let's say 15%. 15%, it just literally means 15 per 100. 15 to 100 or per 100. That's what percent means. You can write it as a ratio. You can also write it as fraction. 15 over 100, or even like this, 15 per or 2. This is the symbol for ratio, 2, 100. And it simply means, let's say 15% off, just means if these were dollars, if an item costs $100, so basically you're saving 15 out of that 100. For every 100 you spend on that item, you save $15. If the item costs $200, how much money will you save with this discount? So for each 100 you save 15. For 200 you'll save. Again, 15% means 15 for each 100. How many 15s are you going to save with 200? It's 2 15s here. Each 100 will save you 15, so the total year discount will be 30 per 200, and so on. If it's 300, of course, it will be 45, and so on. So that's an example of a discount. Or in case of taxes, it adds up. Does anybody know the sales tax rate in New York State?
One more time?
What's the sales tax rate in New York State? So every time you buy something, they charge you taxes. You pay more than what's displayed on the item. What is that percent? What is the exact amount percent of the sales tax of the state?
4%?
Not 4.
4.5?
No, for New York State, it's not 4. Other states maybe, but for New York State, it has its own. It is 8%.
Isn't it 8.8, something like that percent?
Yeah, it's about 8%. Yeah. So for each $100 you spend, you pay an extra amount of $8 for taxes. So if your item displays this, then you go to the cashier, it says price 100, then sales tax 8%, then you get your total 108. Okay, so for each $100 you pay $8, or if you're looking at it in terms of dollars, for each $1 you pay 8 cents in taxes. Okay, so that's this discounts, basically it's discounted for the total amount, but the tax is added up to your total amount. Okay, so this is the idea of a percent. It's just something out of $100 or 100 people, 100 countries, whatever the math is all about. So it's just a ratio, basically. Let's talk about common percents before we get into some, see how to actually find percentages of numbers in detail. For example, 8%, 15, 17. We have some common ones. Let's say, for example, 50%. What do we mean by 50% of something in a word? When you say 50% of something, whatever it might be, what does that mean in one word? What portion? What is a portion here? If you say 50% of something, that means just means half. It simply means half. And as an example, what's 50%? What is 50% of 8? It would be half of 8, which is, okay, half, simply 4. In addition to that, we may have 25%. What do we mean by 25% of anything? So half is 1/2. 1/2 as a fraction. 25% in a word, what is it? So 25% of something, what does that mean? If this is half, what is 25%? Simply means quarter. Quarter of something, or what is quarter as a fraction? 1 out of what? Everybody, what is 1/4 as a fraction? 1/2 is 1/2.
1/4.
1/4, that's right, 1/4. So when you say 25% of something, it just means a quarter of that thing. Let's say you have 12. What is, for example, 25% of 12? What's quarter or 1/4 of 12? A quarter is basically half of the half. So you're going to split this in half and split again in half. So what do you get if you split this twice in half? A quarter means half of the half.
3.
Will be 3. That's right. That's what we mean by quarter. Same way, 75%. How many quarters is that? Think about dollars and coins. 75%. How many quarters? 25 of something means 1/4. 75% of it means 3/4. 3 out of 4. And let's say you have some number, let's say 75% of 8. What is 75% of 8? Or if you divide this into quarters, you take 4 quarters. 3 out of 4. What is 75% of 8? Anybody? So these are the easiest ones. These are supposed to be the easiest percents, the common ones, half, quarter, 3/4, and so on. Before we get to the difficult ones, that's when we use equations and like we saw before, cross multiplying. What is 75% of 8? 8 is basically this. If you divide this into 4 quarters, this is 8. But we only want 75% of it, meaning 3/4. What's 3/4 or 75% of this? That's 1/4, another quarter, and so on. 75 is 3/4 or 3 out of 4. What would that be? 75% of 8 would be? Anybody want to try?
6.
What would it be? 6. That's right, because we take 1, 2, and 3. 3/4 here, that's 6. Again, these are the easy ones. You should be able to do these right away without, having to pull out a calculator or having to do equations. Another one is 100%. So 50 is half, quarter, 3/4. When we say 100% of something, what is that in one word? In one word, 100% of something, what does that mean?
It's a whole.
That's right. This means a whole or everything. So, for example, one out of one, whatever it might be, 1 out of 1 is a simple example. What's 100% of 5? The answer is simple. That would be 100% of 5. That would be the whole thing, which is just 5. 100%. If for everything, don't divide, don't take any portions, unlike these. So these are some of the commonly used ones. You also have 10%, which is 1/10, but at least know these basic ones here. You also have 33%. Does anybody know what 33% is in one word? Something like this. What's 33%? This means 1/3 of something, or 1 out of 3. Example. Say you have, what is 33% of? What is 33% of 6? In other words, what is 1/3 of 6? So 6 is basically this. 2, 2, 2. 1/3 would be 2. 1 out of 3 portions. Okay, now, again, these can be done most of the time without, calculators or equations, but now let's see how to find precise percents when they're not one of these. So the formula for percent is this. A percent we can write as a fraction, as we said before. 15%, for example, is 15 over 100. We call this the whole, and this is the portion. So 100% is the whole, and everything else is a portion. So portion example, 15% is 15 out of 100. So this formula here can solve any sort of problem involving percents. And for example, let's say, what is 20% of, let's say, 5? Okay, so you might not be able to do it easily as these. Okay, 20% of 5. Does anybody know what 20% of 5 right away? It's not too hard to figure out. Does anybody know
4.
it? It will be not 4, but close. What you just said is 4 would be 40%. 4 would be 40%, so we're looking for only 20 of that. That means it would be. Okay, so let's figure it out. So sometimes it's not as.
So it will be 5 because it's 1/5, no?
So 1/5. 20% is 1/5. So what's 1/5 of 5? If you divide 5 by 5, you need to take 1. That would be
It's 1.
just 1. Okay, so 20% of 5 is 1. Again, if you can do the math quickly, that's great. Let's say we don't know that it's 1. Let's actually use the formula to figure it out. So we're going to base it on this. So what you do is you take your percent, you turn it into a fraction. I mean, actually 20%, not 15. Whatever percent it is, turn it into a fraction. Then you need another fraction. So percent is this one. The other one is portion over whole. So 20% of 5. So 5 is the whole. We don't know the portion here. Let's call it x. Once you have that, the rest is simple. We're just going to, how do we solve this equation again? I have two fractions.
Multiply.
That's right, cross multiply. Start with the multiplication of the x, 100 times x. That's 100x. Times the other way, 20 times 5. So 100x equals 100. Divide by this 100, not this 100, this one. Cancel out, so x is 1, as we said. So 20% is another one you may want to add to this. 1/5. So we saw that half is 1 over 2, 25 is 1/3. Think about this as 1/5. So whatever you have divided by 5 and take 1. Okay, so this time we had the whole, but we didn't know the portion. But based on the question, based on the words or the wording of the question, x could be here, or might be here, or it might be even here. So you have to understand the problem and figure out what's missing. Let's do another one. Let's say 3 okay, is 3 is, let's say, 25%. So 3 is 25% of what number? Again, this is not a difficult one. You can probably figure it out without the equation. If you don't, that's fine. We have the formula for that. If you read this here, 3 is 25% of what number? Are we looking for the portion or the whole in this question? Obviously, we do have the percent, so that's not missing. But we need to figure out where does the x go. So 3 is 25% of what number? This number here, is it the whole or is it the portion that we're looking for? So basically, you can say we have a whole number that we don't know. 3% of it, or 3 is 25% of it. 25% is approximately quarter. You can look at it this way. So 3 is 25% of some whole thing. We don't know that whole thing, but we know that 25% of it equals 3. That's what the problem says. So in this case, we're looking for the whole number. not the portion. We need the whole. So the x this time would go here, not here. Here we have the whole. We were looking for the portion. So this time, first I turn 25 into a fraction. And just need to figure out the whole on the portion. So we said again that we're looking for this whole number. So the x should go here. We know that a small portion or percent of it is 3. Small portion, which is 25% of it, is 3. But we don't know the number itself. So this time the x goes here. Now again, we just need to cross multiply to simplify. That's 25x 100 times 3. So 25x is 300. And then you just divide by 25. Divided by 25. X will be, if you cancel these, x will be 300 by 25, which is 12. Okay, 300 by 25 is 12. Okay, so that's pretty much how you solve any percentage related problem, basically by using the this formula here. It solves any problem with percents. Okay, as long as you put x in the right place. So you might be missing the portion, which we did here, missing the whole. Let's do another one here. Let's say 4 is 4 is what percent of, let's say, 12 or 16. This is not too difficult to figure out without the equation. What do you think 4 is what percent of 16? 4 is what percent of 16? Is it a quarter? Is it a half? A third? What is it exactly? In other words, what percent does 4 represent in 16? 16 is what? 4, 4, and 4, and 4. That's 16. What fraction or what percent does 4 represent from the whole thing? We need just one of these. 4 out of 16. So we take 1 out of these portions. What is a fraction here? 1 out of what? We take a fourth. 1, 2, 3, 4. We take 1 out of them. What is 1/4 again as a percent? 1/4 is 25%. Okay, let's see you didn't see it, okay? Let's do it the slow way. Okay, so you forget about that, don't worry about it. Let's do it the easy way. So what are we missing here according to the problem? Are we missing the portion, the whole, or the percent? If you look at this, clearly we're missing. What is missing here? 4 is what percent of 16? Clearly, we don't know what the percentage is. So where do we put the x? Where does the x go here? If you're missing percent, so here we're missing the portion, here we're missing the whole number. In this problem, we're missing the percent. So where do you think the x goes? For example, in this example here, where do we put the x? Okay, so this time we do not know the percent. So that's where the x goes. If we know it, we write it like this right away as a fraction. If we don't, and that's basically what we're looking for, the x should be over the 100 because we don't know what percent it is. And the other two numbers should go here, portion over whole. Okay, we should get them from here. So what over what based on this problem? What's the portion and what's the whole in this example here? Anybody? What is the portion or whole? How do we set up the other fraction? Obviously the whole is the larger number, that's 16. And of course the portion of it, just 4, a little bit out of 16. Okay, so if you're missing the percent, the x goes here, and you should have the other numbers. If you have the percent, you write it here, and the x will be either here or here depending on the question. Here we're gonna say 16x, 100. If you divide by 16, divide by 16, so x would be, what percent is this? It would be quarter, as we said earlier. Divide this by this, it would be 25. And of course, since we're looking for a percent, we have to add a percentage sign to it. Only do that if you're looking for a percent. Not here. Here, it's not a percent. We were looking for the whole number. We had the percent, just 12 without the percentage sign. Same thing here. We were looking for the portion. That's why the answer is 1, not the percent. But if we looking for a percent, we have to add that percentage sign to the answer. And that's pretty much how you solve your problems involving percents using equations, okay? These again, be familiar with them. It's gonna be easy. If not, it's not a problem. Just turn the problem into a short, easy equation, cross multiply it, and you'll get your answer. Okay, everybody, any questions about any of this?
No.
Everybody else, you guys okay? Any questions?
No, I'm good.
Okay, so that's pretty much it for today. There's gonna be, you'll see plenty of these exercises in the homework, just like this, okay? No big deal here. Ratios, okay, you can find the missing numbers, cross multiply to check proportionality and to find x. From now on, anytime you come across a word problem with a missing quantity, it's very practical and believe and easy to solve if you use this. You don't have to guess numbers or try different combinations. Just right away turn that into two ratios and cross multiply. It shouldn't be that hard. Of course, any question involving percents, this is your base formula. Solves all sorts of problems. Even if the percents are not as common like these. Any question can be turned into an equation, cross multiply and solve, but be careful where to put the x. It's based on the understanding of the problem. Could be anywhere here, here, or there. So read the problem a couple of times. Make sure you put the x in the right place. Otherwise, you may not get the answer or the correct answer you're looking for. What else? Okay, so that's pretty much it for today.